In a previous class, we've talked about atoms having atomic weights. If you remember on the periodic table, we can find the atomic weight of an atom generally below the symbol for that element. So for hydrogen, we might find its atomic mass or atomic weight below and beryllium below its symbol. This is where we can find its atomic mass. Sometimes we might call it atomic weight as well. But what about molecules? We can also, it turns out, find molecular weights or molecular masses. So I have a definition here. A molecular weight we can define as the sum of the atomic weights or atomic masses for each atom in a molecule's chemical formula. Okay, and again, these atomic weights are found on the periodic table, like the one I have shown on this page. So let's cover now how we can achieve calculating a molecule's molecular weight. Let's start out with something simple. If we take one hydrogen atom and we look on the periodic table, we see that it has an atomic mass of 1.008 atomic mass units. And we generally abbreviate this AMU, and we're going to do that here. If I have a molecule that is composed of two hydrogen atoms, in this case it's molecular hydrogen, then in order to determine its weight, because I have two hydrogen atoms, I'm going to take the atomic mass of one and add it to the atomic mass of the second. And what I'll get is the sum for the molecular weight for the molecule, which is 2.016 atomic mass units. Okay, so this is my molecular weight for H2, or molecular hydrogen. Okay. We can do something similar if I have a molecule that is made up of oxygen. Well, oxygen has an atomic mass of 16.00 AMU. And it's always best to use at least two places to the right of the decimal point. Okay, so if I have a molecule that's composed of oxygen, but it has three oxygen atoms, this happens to be ozone, then its molecular weight is the sum of all of the oxygens in the formula. So I can calculate by adding up each of the three masses. Okay, and this will end up being equal to 48 AMU. So notice in this case I added up all of the values, but I can calculate it a second way. Notice all the atoms have the same mass. It's the same atom. And I have three of them, so I can achieve calculating the molecular weight here by multiplying 3 times the 16.00 atomic mass units, and I should also get 48 AMU. I should actually put some zeros here as well. So I'm going to do one more example for a molecule that's a little more difficult than the ones we've already talked about. So let's consider calcium hydroxide. Okay, so in order to understand the number of all the atoms that exist, let's go ahead and write it out. So the formula tells me that I have one calcium atom, but it also tells me that I have two of these OHs. And remember, this OH with the minus is the hydroxide. Okay, so within these two OHs, however, I can expand that. So this is an OH plus a second OH. And within these, you can hopefully see that you have two oxygens plus two hydrogens. Okay, so all together now, we have one calcium atom, we have two oxygen atoms, and we also have two hydrogen atoms. Okay, so now that we understand the number and type of atoms in the molecule, we can simply add all the masses to obtain the molecular weight. Okay, so we'll start at the left. So calcium, if we look on the periodic table, has an atomic mass of 40.08 AMU. We have two oxygens at 16 AMU, and we'll add to that 2 times 1.008 AMU for the hydrogens. When we plug this into our calculator, we should get a value of 74.096 AMU. So here we have the molecular weight for calcium hydroxide. So in summary, if we want to calculate the molecular weight of a molecule, we simply add the atomic weights for all of the atoms that exist in that molecule's chemical formula.